This lesson is the first of 3 lessons that we're going to learn about trigonometry, which is using triangles to make measurements. And you can see the word trigonometry comes from the prefix broken down. It's trigon or triangle and metry for measure. So using triangles to measure things. Now this particular lesson is really important because it's got a lot of vocabulary and formulas that are going to help you really understand the lessons to come. So take careful notes on this one and rewind and pause if necessary. Now, to get some things out of the way, we need to learn about how we identify certain parts of a right triangle. Some of this you'll already know. For example, you already know that there's a right angle and that across from our right angle we always will find our hypotenuse. So that's some old stuff. We use that with the Pythagorean theorem. Well, these other legs over here and here that form the right angle, we're going to give those some special designations based on what we're going to call the angle of perspective. So I want you to imagine you're looking at this angle here at the bottom. This is going to be the angle that we are going to focus on as we name the other legs. Now, this angle, our angle of perspective, maybe I should write that down. This is the angle of perspective. It means that it's the angle we're going to focus on as we label the rest of the parts of this triangle. This angle lies opposite or across the triangle from this leg here. So we call this leg the opposite leg. And again, that's because it lies across the triangle from our angle of perspective. Now the second leg right here along the bottom, in this case, is lying adjacent to the angle of perspective. We call it the adjacent leg, and I am out of space to write that. Adjacent leg, and adjacent still means that it's right next to or connected to our angle of perspective. Now, why does this angle of perspective matter so much? Well, let me just show you. If we had a different triangle, maybe it could even be turned or something, then we're still okay finding the right angle. It's going to have the right angle mark, and knowing, of course, the hypotenuse is across from that, and I'll just start abbreviating here. But which leg is the opposite leg? It depends on which angle we're looking at. If, for example, this is my angle, then I'm going to find my opposite leg over here. If this is the angle, then the opposite leg's on the other side. So it all depends on where the angle that we want to use is. So we need to identify where our angle of perspective is. If this is the angle that I want to use, then I'll want to call that the angle of perspective. And I will then be able to label things from there. So across from the angle I'm using, I find the opposite leg, and connected to the angle I'm using right here, that would be the adjacent leg. So you're going to need to know how to identify those different parts. And we're going to use them as we look at what are known as the trigonometric ratios. There are 3 of them that we're going to use: the sine ratio, the cosine ratio, and the tangent ratio. Let me show you what those are. First, the sine ratio. The definition of it is the sine ratio for the angle of perspective is equal to the length of the opposite leg divided by the length of a hypotenuse. And that's a lot to say, and it's a lot to write down too. So we're going to simplify that or abbreviate it to look like this. The sine of our angle is equal to the opposite leg over the hypotenuse. And this is what we're going to build equations with. So in our diagram, we would have to have our angle of perspective. That would be here. We would have to know it's a right triangle, or we can't do any of this. And we would have to build a sine ratio by pulling the opposite leg, the length of that leg, 12 inches, 5 inches, whatever it is, dividing that by our hypotenuse value. And so the sine ratio uses the opposite leg and the hypotenuse, along with our angle of perspective, to build an equation. The cosine ratio is kind of similar to that. The cosine of the angle of perspective is defined to equal the length of the adjacent leg over the length of the hypotenuse in a ratio. And again, we have an abbreviated form of that. The cosine of our angle is our adjacent leg over the hypotenuse. And what that looks like on our diagram is, with our right triangle established, if we choose our angle of perspective, then we want to pick out the side that's adjacent to that angle. So we would use this side, the adjacent side, and along with it the hypotenuse across from that right angle. The tangent ratio is our last one, and it looks like this. The tangent of our angle of perspective is the length of the opposite leg divided by the length of the adjacent leg. So abbreviated form, it's tangent of the angle is the opposite leg over the adjacent leg. And in a diagram, with a right triangle given, we would have our angle that we want to look at point us to the opposite leg across from it, and we would use the adjacent leg. You'll notice that there's no hypotenuse involved in our tangent ratio, just the opposite leg and the adjacent leg to build those. Now we're going to work with these for the next few lessons, but your goal today is to be able to recognize which ratio is involved in a triangle. Now, we do have a way to remember these ratios. That's some things you got to memorize. So here's a little memory trick. This, ladies and gentlemen, is who I like to think of as Sokotoa, who is the Greek goddess of trigonometry. Now, if you ask some other people, they'll tell you some kind of story like Sokotoa was some Indian princess or an Indian chief. But I believe that Sokotoa was a Greek goddess because I know that she and Pythagoras, who was a Greek, they had some relationships going on. In fact, if you take pre-calculus, you'll get to hear about their whole love story. But they ended up dating, falling in love, getting married because of the right triangle. They both love right triangles, Pythagoras and Sokotoa alike. But this is a way to help you remember those three formulas that we just saw. Let's take our first name here. So that's sine of our angle equals the opposite side over the hypotenuse. Now this is abbreviated form, but the sine is the opposite of the hypotenuse. The so part helps you remember that. Now ka, her middle name, is to help you remember that cosine is equal to, the cosine of the angle is equal to the adjacent over the hypotenuse. So CAH means cosine is adjacent over hypotenuse. And then last one, tangent. The tangent ratio is the tangent of the angle is equal to the opposite over the adjacent. Sokotoa is to help you remember and keep those straight, those formulas straight. But at any rate, you must be able to label and recognize in the triangle the parts. If this is your angle of perspective, your opposite leg is across from that angle of perspective. Your adjacent leg is connected to it. And this last side is always called the hypotenuse, found right across from the right angle. And by the way, something really important to know, and you should write this down, the right angle is never the angle of perspective. It's one of the acute angles every time. So jot that down too. All right, your goal for this lesson is to be able to recognize these different parts and different ratios when they're being used. So first, let's practice identifying the angle of perspective. That's our marked angle in red here. And the adjacent, opposite, and hypotenuse in each diagram. So let's take our angle of perspective and let's start by going right across that triangle and find our opposite side. Label that as opposite. Label the side right next to that angle that runs to the right angle. Label that as adjacent. And finally, this side over here, this is hypotenuse. That's all you got to do for that example. Try it on the next one. Angle of perspective is R. Go across the triangle and you'll find the opposite. Label it. Connected to that angle, to the right angle, is the adjacent. And always opposite the right angle is the hypotenuse. So you need to be able to label those and identify them. Also, you need to be able to finish the formulas. So Sokotoa here will help us do that. For sine, I'm going to put the opposite over the hypotenuse. Let's label those first. Now notice in this first set that H is our angle of perspective. So let's go mark that. This is our angle of perspective. Let's go across the triangle and we'll make 12 the opposite. Next to the angle of perspective, going over the right angle, that's the adjacent. And then, of course, we have our hypotenuse. Our longest side is 15. So let's build our fractions. The sine of h is the opposite side over the hypotenuse. So looking at my picture, it looks like 12 is the opposite side and 15 is the hypotenuse. So I would put 12 over 15. And then, since I can, I'm going to reduce that. Dividing both of those by 3 is going to make that 4 over 5 for my final answer. The cosine of h. The cosine of h from Sokotoa, cosine is to take the adjacent over the hypotenuse. Adjacent was 9, hypotenuse was 15. So this would be 9 over 15. And that also goes down to a 3 over 5 if we reduce. And then the last one, tangent from SOHCAHTOA, it's opposite over adjacent. Let's put 12 as our opposite, over 9 as our adjacent. So 12 over 9 is our ratio, and that reduces down to 4 over 3 for my final answer. Now you might look at this and think this is the same problem, but look, the thing that has changed on it is that angle of perspective. It's P now. Instead over here it was H. So that means I have to start from scratch and I have to relabel the whole thing using P as the angle of perspective this time. So with P as the angle of perspective, that means that my opposite leg is now 9 and my adjacent leg is that 12 that's connected to angle P, with the hypotenuse still being 15. That's not going to change. So now the sine of angle P would be 9 over 15 because I'm taking my opposite side over my hypotenuse. That reduces down to 3/5, just like it did up there. The cosine for P, cosine, SOHCAHTOA tells me that cosine is A over H, or adjacent over hypotenuse. So let's make that 12 over 15, or 4/5. And the tangent is to take the opposite side over the adjacent side. So 9 over 12 will reduce me down for my final answer of 3/4. And the last thing you really need to be good at is to write out the whole equation using the 3 indicated parts. Now the right angle is always going to be there. In fact, if you don't have a right angle, you can't use these definitions. What you're going to be looking at is what angle of perspective and what 2 sides do they give you to choose. So let's start by labels. Angle of perspective is A, and that makes this the opposite side, little side A over here. And what is C? C is across from the right angle, so C is the hypotenuse. Now think to yourself, if SOHCAHTOA were here, and let's put her here, if SOHCAHTOA were here, which ratio would she pick in order to pair up the hypotenuse with the opposite, the O and the H? She would use, for O and H, she would use the sine ratio, the one that starts with S. So this answer is this. The sine of angle A is equal to little side A over little side B there. That's what we're looking for these. Try it with this next one. Angle B is your angle of perspective, so what does that make X and Y? Well, Y is across from the angle of perspective. That means it's the opposite. X is connected to the angle of perspective, and so that makes it the adjacent. And yep, sure enough, the hypotenuse is right down here as it's across from the right angle. So ask SOHCAHTOA, what would she say if we had to pair up the adjacent and the opposite sides? She would want to use the tangent ratio. And so it would be set up this way. The tangent for the angle B is equal to the opposite side, which is Y, over the adjacent side X. And then you're done. If you can do this, you'll be really successful with the next lesson. So check yourself. Okay, one last example. Angle T is the angle of perspective, so what are these sides U and W? Well, the side across from them is opposite, and that's the side that I don't care about. So that makes angle U the side adjacent. It's connected to T, and W is opposite the right angle, so there's my hypotenuse. SOHCAHTOA could tell me to use adjacent and hypotenuse by building a cosine ratio. The cosine is the adjacent and the hypotenuse together. So I would say this, the cosine for my angle, and my angle's name was T, the cosine of angle T is equal to the adjacent side, which was U, divided by the hypotenuse, which is W. Can't even tell that's a U. It looks really bad. All right, got it fixed. All right, and that's my setup for my equation.